Let's talk about the concept of activation energy, okay? Activation energy is the minimum amount of energy needed for collisions between molecules to be effective. And what that means is if you have two molecules, let's say we have A plus BC, so that's a molecule, there's a bond between B and C. This forms, so there's a new bond that forms between A and B, and then the bond between B and C breaks, you see. So for the, if you take BC and you react it with A, those two molecules, they have to collide with each other. And for those collisions to be effective, they have to attain a minimum amount of energy for the bond to break. Once the collision takes place, the bond between B and C is going to break, and a new bond between A and B is going to form. Okay, so that's basically what activation energy is. If you depict activation energy on an energy profile diagram, we can kind of show it out here. You have the vertical axis. Let's put our potential energy on the vertical axis, and then on the horizontal we have our reaction progress. So if we put our reactants, let's say our reactants are at this energy level, that's the level of the energy. So now activation energy, that means when they collide you have to put in energy, so therefore the energy is going to go up, right? Because you're giving it more energy than it has to begin with. So the energy going to go up, and then out here in this particular case what's going to happen is the bond between B and C is going to break, and a new bond between A and B is going to form. So what you're going to have is something that looks like this, where there's a new bond forming between A and B, and then there's the old bond between B and C is breaking. So these are kind of elongated. This state is also called a transition state, okay, because you're transitioning from reactants to products. But once it reaches the transition state, that bond completes forming and that bond completes breaking. So then they attain stability, and then that tumbles down into the products, which is AB plus C. Okay, now the amount of energy that A plus BC go up by to achieve this transition state is the activation energy. So we can kind of map that out here. That is my activation energy. That is denoted by a capital E subscript A. So that's my activation energy. Now, a couple of things about activation energy. Number one is activation energy is only dependent on the nature of the reactants. Okay, depends only on the nature of the reactants. The second thing is activation energy is always a positive quantity. So EA is always greater than 0. The third thing is activation energy is not dependent on temperature or concentration. Okay, and the fourth thing out here is if you have a fast reaction, that means activation energy is small. What if you had a slow reaction? Then activation energy would be large. All right, hope that made sense.